Hello friend, welcome back in our online lecture series. I am Dr. Keshao Mahale and we are going to discuss the new rearrangement, Pinacol-pinacolone rearrangement. Friend, the substance which having tertiary 1,2-diol are known as the pinacol, and when such a compounds um, when react with the sulfuric acid or mineral acid, so the sulfuric acid is from dilute to the concentrated, then there is a formation of ketone, and such a specific ketone which having the 3-hydroxy ketone is known as pinacolone, and this rearrangement therefore is known as the Pinacol-pinacolone rearrangement. Friend, this reaction is also known as pinacolic rearrangement. So here is the conversion pinacol to the pinacolone. Pinacol is the tertiary 1,2-diol. Let us see here the conversion. See, this is R group is here. This is OH here. This is R group here. This is COH. This is R group and this is R group. See here, this is tertiary carbon, this is tertiary carbon, and there are the 2 hydrogen group at one position. Therefore, such a type of compound generally are known as the pinacol. And when such pinacol is react with concentrated or moderate H2SO4, then it will be give us the ketone. The ketone will be like this. See, this is the R group. This is C double bond O, and this is the R group. This is the this R will be shift here. This is carbon. This is R group. This is R group, and this is R group. So this is nothing but the pinacol. This is nothing but the pinacol. So simply see, this is the pinacol, and when this pinacol is react with concentrated sulfuric acid, then it gives the pinacolone. Let us discuss here the mechanism. See, this is R, this is OH here, this is another R, this is another OH, R group, this is R group. When this compound will react with concentrated sulfuric acid, which will be gives an H plus ion, and the lone pair of oxygen will attach to this H plus ion proton, and there will be protonation. So this is the OH, this is the R group, this is the R, this is the OH twice plus, and this is R group, this is R. Now this OH twice plus will be removed from here, as this is the good leading group. We got here the classical carbocation. We got here the classical carbocation. This classical carbocation, then after this classical carbocation, then after see this classical carbocation, then after will converted to the non-classical carbocation when this R will be shift here. See, this is the classical carbocation. Classical carbocation. This classical carbocation will shift further to the non-classical carbocation. This is C. This is R group here. This is another R group here. And see, this is the R group which will be migrated from one to two position. So this is non-classical carbocation. This is non-classical carbocation. Now this non-classical carbocation will be again converted into classical carbocation. See, this is the OH here. This is carbocation, this is carbon, this is R here, this is R group, and this is the R group. See, the conjugate base now, the conjugate base that is HSO4 minus. Now will take this hydrogen, this bond will be shift, and finally we got here the pinacolone. This is R, C double bond O. This is C, R, R. This is R. This compound is nothing but the pinacolone. So in a such a way, we got here the pinacolone from the pinacol by adding the concentrated sulfuric acid, and hence this rearrangement is known as the pinacol to pinacolone rearrangement or pinacolic rearrangement. Let us discuss now the stereochemistry which present in this type of rearrangement. So, what is the stereochemistry in this rearrangement? Migrating group should be antiplanar to the living group. For this, we are taking here the example. See, here is the CH3, here is the CH3, this is OH here, and this is the OH here. When such a compound, see, this CH3 is toward the one side, OH is toward the one side, so therefore this is the cis derivative. When such a type of compound will react with the concentrated H2SO4, then after the protonation there will be formation of OH twice plus, this is CH3L, this is the OH here, and this is the CH3. See, this leaving group and this CH3 are antiplanar to each other, and hence this CH3 will be shift here and this OH will be removed, and we got here the new compound. It will be like this. See, this is the C double bond O, and this is the C, this is the CH3 here, and again this is the CH3 here. So antiplanar, this CH3 is the antiplanar here, and we know that when leaving group will be removed, so antiplanar group will be shifted here. So in next case, I will take here the trans conformation. This is the CH3 here, this is OH here, this is OH here, and this is CH3 here. So when this trans isomer react with concentrated H2SO4 by the protonation, it will be form a good living group. This is hydrogen group, this is the CH3 group, this is the OH twice plus, and this is the CH3 now. See here is alkyl group is not more transplanar, and hence this alkyl group is not transplanar, and hence this bond will be created shift here, and we got here the 5 membered. We got here the 5 membered ring. See, this is the 5 membered ring. See, this is 1, 2, 3, 4, and 5. This is 5 membered ring, and at this position, here is a 1 CH3, and this is the C double bond O now, and this is the CH3 here. So, in the stereochemistry, we can judge here the anti-pleniplanar or trans-periplanar group will be more here. So, let us discuss here the example. See, this is the example. When this compound will react with the concentrated sulfuric acid or sulfuric acid, will be gives the protonation, and after protonation there will be formation of good living group. See, this is the another ring, and here is the OH twice plus this is the good living group here, because concentrated structure will be H plus ion, the lone pair will be attacked here, and here will be the formation of good living group. So in this case, this will be water will be removed here. So after the dehydration, we can write the new structure in a such a way. See, this is the OH here, this is the OH here, and here is the positive charge, here is the positive charge. Now in next step, the conjugate base HSO4 minus ion takes this hydrogen, this bond will be shift here, this bond will be shift here. So we got here 1, 2, 3, 4, 5 and 6 membered. See, this is the 6 membered ring. Again, how the 6 membered ring is formed here? See, this is 1. This is 1, 2, 3, 4, 5 and this is the 6. 6 membered ring will be formed here. See, this is the carbonic group, and then the next ring is attached to this next carbon, and which will be the 5 membered ring. So here this compound will be formed here. So this is the example of Pinacol-pinacolone rearrangement. Another example of Pinacol-pinacolone rearrangement. See, this is one example. One example given in the previous examination question paper. See, this is the pinacol when react with the acid. So firstly, we can make here this hydroxyl group into the good living group by taking this proton by the protonation. So here will be the formation of new type of compound like this. This is the 5 membered ring now, and this is OH here, this is the pH here, this is OH twice plus, and this is the pH here. Now this OH twice plus is the good living group, and after the dehydration we got here the carbon. See, this is the carbon. This is hydroxyl group here, pH here, this is carbon, and this is the pH here. Okay, see here the conjugate base HSO4 minus ion will take this proton, and this bond will be shift here, and this whole phenyl ring will be shift here, and we got here the final compound will be like this. Here is the carbonyl group, and here is the pH, and here is the another pH. So this is the final compound. So this is the Pinacol-pinacolone rearrangement, in which we can convert the pinacol into the pinacolone by using the concentrated sulfuric acid.